Welcome back to Geometry, Measurement, and Probability. In this video, we will be looking at section 14.2 and talking about reflections and glide reflections. So let's get started. Another type of isometry is called a reflection or a flip. Now, one type of reflection that we see in our lives is a mirror image. And the line across which the image flips is called the reflecting line. We can obtain reflections in many ways, and one way is to fold the paper across the reflecting line, and drawing the image gives us the mirror image, or the image in this case of a half tree. In example 1, we are asked to find the image of triangle ABC under a reflection in line M. What's going to happen here is each of our points are going to be the same distance from M, but they're going to be across M. Now C and C prime are the same since C is on line M. Notice that A is 1 away from D. So when I reflect A across line M, I am still 1 space away from D, and so I have my new point A prime. Think about B. B is 3 away from D, and when I reflect B across M, B is still 3 spaces away from D. Connect your new points to make your triangle. In example 2, we reflect our figure across the given line. So if I think about drawing that mirror image, my image looks like this. Now, some reflecting lines in a coordinate system, like the x-axis or the y-axis or the line y equals x, are pretty easy for us to find the coordinates of the images. With the x-axis, we go from above the axis to below the axis or vice versa. So that changes the sign of our y. For the y-axis, when we reflect across the y-axis, we go from the right side of the graph to the left side of the graph or vice versa. This changes the sign of our x. Now for the line y equals x, we switch our x and our y. Here's how this works. So here we have the line y equals x that we are reflecting across. We have the point A, which is the point 1, 4. When I switch the x and the y, because I reflect across the line y equals x, my new point A prime is 4, 1. The same thing happens with B. My new point B prime, I switch the x and the y, and so that new point is 0, negative 3. So let's add a point to our graph. Add the point negative 1, 2 to your graph, and this is point C. I want to know what's the image of C when I reflect across the line y equals x. Well, my image is C prime, and when I reflect across the line y equals x, I switch the x and the y. And so my new point is 2, negative 1, and I draw that point on my graph. So look at example 3. We are given 3 points, and we want to find the coordinates of these points under certain transformations. So first, we have a reflection in the x-axis. So we talked about a reflection in the x-axis moves our point from above the axis to below the axis or vice versa. That changes the sign of the y. So for A, my new point A prime would be 2, negative 3. I change the sign of the y. For B, my new point would be B prime, 0, 1. For B, my new point would be B prime, the point 0, 1. My sign of the y changed. And for C, my new point is C prime, negative 2, 3. Again, notice that the sign of the y changed. Look at part B. When we reflect in the y-axis, we move from the right side of the graph to the left side of the graph, or vice versa. This changes the sign of the x. So in part B, my A prime would be negative 2, 3. The sign of the x changed. For B, I can't change the sign of 0, so that point stays the same. And for C, my new point C prime would be 2, negative 3. Notice the sign of the x changes. Last, in part C, we reflect across the line y equals x. This switches our x and our y. So A prime would be 3, 2, B prime would be negative 1, 0, and C prime would be negative 3, negative 2. Last, we have what's called a glide reflection. So this is a translation followed by a reflection. Look at example 4. We have a glide reflection determined by the slide arrow OP, where O is our origin and P is the point 0,4, and we are reflecting across the y-axis. So first, let's think about the translation, and then we'll think about the reflection. So with my translation, I'm moving from 0, 0 to 0, 4. The x didn't change, but the y went up 4, so that would be represented with y plus 4. Then I think about my reflection. The reflection is across the y-axis, and so the sign of the x changes. I start with units from the translation, and I change the sign of the x, and then I bring across that y. So if we have the point 2, 3 in part A, we want to know what is the image of that point under a glide reflection. We have our formula. It's negative x, so A prime would be negative 2. And then y plus 4, so 3 plus 4 is 7. Now look at part B. In part B, we're given B prime, or the image of B, under the glide reflection. And we want to find the coordinates of B. Now remember, the coordinates under the glide reflection are negative x and y plus 4. So B is the opposite. The x coordinate of B would be the opposite of 6, which is negative 6. Then to find that y coordinate, I want to think what plus 4 gives me 1? Well, that would be negative 3. In part C, we're asked to write a general formula for the point xy under this glide reflection. We've already done that in negative x comma y plus 4.